Hey guys, I hope y'all are doing good. This is the part two of my podcast with Professor Diego Garcia. We earlier had discussed a lot about computational design, parametric architecture, AI, and so on. In this part, we'll be discussing more about 3D printing. We'll be discussing about computational design and pairing it with BIM. We will be discussing more about robotic arms and how it functions. So, this will be a very interesting part. But if you haven't seen the part one, I would strongly recommend all of you to watch the part one as well. And yep, without any delays, let's get started with the video. So my next question is, can we, because computational design and like parametric architecture, there are few major softwares that run into it, like Rhino, Grasshopper, and all these things. But is there a way to integrate BIM with parametric architecture? Can we get parametric model or parametric elements into BIM, and can we schedule it? Can we get quantities out of it? Can we basically use it for construction drawings as well? I'm not sure how it works.
Mm-hmm. I can talk about what I know that is Rhino, no? So there is a plugin called Rhino Inside, and so there are some apps that you can use to connect with other software. And so there is one called Rhino Inside Revit, and then you open your Revit, Rhino, Grasshopper, and you're modeling in Grasshopper, and you can link it with families from Revit. And so at the same time you're modeling in Grasshopper, it appears in Revit with the information of a family in Revit. It's not just a mass that you import without any data. No, it is like a model that it's like if you are manipulating Revit from Grasshopper with advantage of working with parametric design.
Wow. So we can do that through Grasshopper in Revit.
Yes, yes.
Wow.
And that's called Rhino Inside Revit. And this Rhino Inside works via API, application programming interface, to enter into other software. So if you know how to program a little bit to connect Rhino Grasshopper with other software, you could do also the same. But the most popular right now is Rhino Inside Revit.
Wow. Okay, I had no clue about this.
Search for that, because as an expert in Revit, and you have some knowledge knows of Rhino Grasshopper, you will see how suddenly everything links.
Wow.
It's not working perfectly yet, but it is improving, and every time you can the interoperability is much better.
Because I did import Rhino model into Revit, but it was just like a solid block, and I was like, now what?
It's just construction mass.
Exactly. Like now what should I do with this? But yeah, I will probably do a hands-on with that. So
and also there is one more plugin called Visual Arc in Rhino that works with IFC files, and it is BIM, but in Rhino. It's not obviously that advanced as Revit, but it makes a lot of things in BIM environment.
I sometimes I really hope that Revit or some other software comes up where it doesn't need a third-party software or something. It just has that kind of functionality within itself, so that we can have BIM and parametric architecture together, and we can have a quantitative data as well. And that will be the point, I think. So it will change the game for everything. The buildings and the models that we see around the world will just change. The architecture itself will change everywhere.
You have a Dynamo, no?
Yeah.
It's kind of
Dynamo is kind of near to that, but still it struggles with complicated models and complicated structures. So as we speak about computational or parametric architecture, where you have like seamless flow of surfaces, where you can manipulate the geometry, every instance of that geometry is also manipulated by Grasshopper. That is still something that is missing in Dynamo. Like you can do that. You can do that with families. You can do that with your walls, windows, all those stuffs. But I feel like Revit restricts you. It's like it ties you up. It says like, no, you are not going ahead of our families or ahead of the massing models that we make in Revit. So that is something still I'm just craving. If someone comes up with something like that.
Yeah. So it's kind of an extension, but inside the Revit world. It's not, you cannot
Yes.
work from scratch. You're
Yeah.
fixed to the family system and everything, no?
Yeah. And I feel sometimes Revit, the interface is so old that we have to use Dynamo to do menial tasks which can be already integrated into it. For example, if I have to change line styles, so we have different lines, right? Like straight line, dotted line, dash dot, construction, demolition, all these lines. And if I want to change a certain line style in a project, I use Dynamo. I have made a specific Dynamo flow where I just insert, like replace line style 001 with line style 002. So what Dynamo will do is it will go through my entire project and all the line styles, it will go ahead and replace it everywhere. So that's how we are using it for now. And similarly goes for windows, doors, and all these things. As you said, like you can control small data points and you can control what to change and what not to change. So we are just doing that. We are not going into the parametric part of it yet.
Understood. Okay.
Yeah. So my next question is about what should a young architecture student should focus on? Because at this moment, I also get confused sometimes. I just suggest all the students to just focus on Revit and all the hard softwares that are there for architecture. But I'm not sure what should they focus on. Should they just go for parametric architecture? Should they learn some programming, Python language or something?
It's complicated. And for I don't know. I when I talked to the students last year, they tell me that they learned maybe during the studies, I don't know, 12 different software: AutoCAD, Rhino, Revit, SketchUp, Excel for calculation of thermal isolation, blah, blah, blah. And in the end, it's like, is it necessary? And I don't know. The thing is that you don't know where you're going to work. Okay. And so the advice from my side would be learn a little bit of everything. I mean, it's possible to be an expert on any software when you are studying. Learn to do complex modeling, algorithmic design, BIM, learn how to render, learn AI, try experiment with AI as much as you can, and of course, hand drawing. Hand drawing is super important. Hand drawing is super important because for me it's always the fastest way to express your ideas. Maybe with AI, no, but before AI, it was the fastest way to express your ideas, the hand
Yeah.
drawing with a pencil. So also don't forget how to draw by hand. But my advice would be learn a little bit of everything because when you will start working in the office, they will tell you, here we use MicroStation. I'm like, what? We use MicroStation? Yeah, you have to learn MicroStation. It's like, okay. And then you move to another place, and here we use AutoCAD and 3D Max for running. I was like, okay, I know a little bit. Okay, then you will master it in a couple of months. Or here we use just Grasshopper, but Grasshopper is not enough because you need to know Python, C Sharp, and how to code everything. It's like, so
What to do?
in the end,
Yeah.
it's impossible to know everything. So the best thing is to learn a little bit of everything. Then you will see where you finish. For example, when I was studying, it was only AutoCAD, the only software. And I thought, when I finished, I said, I don't know many things. I don't know real world. I don't know how to make a building. But if I'm sure of something, is that I know how to use AutoCAD. What happened? I went to work in my first company. and they told AutoCAD, of course. Okay, here is the base file. We use it as an external reference, and so that file you cannot modify it, and you have to link it as an external reference and use it. Blah, blah, blah. What? I didn't understand anything, and so I had to learn kind of advanced AutoCAD to start working, and it was the only thing that I was sure about. So learn a little bit of everything, and let's see where you finish, and there you will have to do some courses or study more and master the software that the architectural practice is using at that time.
Yeah.
Because everybody says that everything is going to be BIM, and that when you finish a building and you get it to the Office of Architects of the city, you have to send also the IFSC file, and everything is going to be BIM, and you're not going to print plans. It's not true. I mean, it's not true. I mean, maybe that could be true in many years, because they said, no, there's going to be a law in Europe that everything has to be BIM in 2 years, blah, blah, blah. It's impossible. It's impossible. Yeah. So not even BIM that was supposed to be by law is gonna be fast implemented.
Yeah, because here in Canada we are in stage 2 of BIM implementation. I think so. UK is proceeding to I think so stage 3, where they will have all the building approval done by using BIM. So they have to use BIM as a software. But right now around the world, the major debate is going on of one software or one company controlling a major stake of construction industry around the world. And you know what that company is? Autodesk. It just controls everything. So BIM is basically not Revit, but it is Revit for now.
BIM is not supposed to be Revit. Revit is one software that works with in the BIM environment. BIM is a lot more, no? But the Autodesk did it super well, because you say BIM and someone says Revit. No? It's like, oh.
And they acquired all the companies that are coming up. So if some company is coming up, oh, this company is doing something nice, Autodesk, buy it.
Yeah.
So that's a very big, scary thing that is going on in the world right now, especially in the BIM industry. I would say that how can we diversify? Because sometimes it has happened since I'm in Canada, twice it has happened. The server went down and we all had to go home from office because our models are on cloud. We can't access anything. We can work locally, but what if I have worked on something and someone else has worked on something, and when we sync, we can't sync because we are clashing with each other. So yeah, so these are the things that are happening in BIM for now.
Interesting, very interesting also.
Coming to the next question, what do you think how an architect can grow into this field of computational design? Is it just learning new softwares, applying for it? Or for example, I learned the software, I know my skills. So while applying for a company, how can I apply? How can I show them that I am valuable enough? Is it just my portfolio, or I have to be something extraordinary out of the box? Like, what should I do to get hired into computational design? Because I think so very few companies are doing computational design, right?
Right. Very few companies, not in every country. I think it's the portfolio is the main tool nowadays to try to enter in any company. They don't even are going to ask you for your marks at the university, I guess, or anything. They want to know if you really can handle in projects the algorithm, the data, and everything. And so I would focus on preparing a good portfolio with your projects and so on. But the way you're really going to learn properly computational design is putting it into real practice, because real problems are completely different than just student problems. Because when you want to do something not that big, I mean, then kind of a sculptural thing for an artist or so on, that everything has to be 3D printed and CNC mill and design in Grasshopper, that every single thing is different and so on. There you see really the complexity of everything, because reality manufacturing is different from a scale 3D printed model, or from just paper or images, plans, and so on. So just try to learn as much as possible and prepare not a beautiful portfolio, an efficient portfolio where you can show really your skills. That would be the best advice for someone that is finishing their careers, their studies, and they're trying to look for something. And obviously they will have to start as everybody started, no? Like at the bottom of the pyramid in the office. And then that's the moment where you have to show your value and your skills, of course.
So I have seen on your Instagram, you have done something with robotics as well. I saw that robotic arm or something, the movement of that arm or something like that. How was that done? What software do you use do you program that robotic arm to generate those?
That's part of our master in parametric design. That is a hybrid edition that 3 months they study online with different teachers from the whole world. And then they come 1 month to our headquarters in Madrid to put everything into practice with different digital fabrication tools, as 3D printers, milling machines, and also the robotic arms. We program them with Grasshopper. We do everything in Grasshopper. I don't know why. I always have this joke with people. I say, you can use Grasshopper for anything. Even you can win the lottery with Grasshopper. I made a video in YouTube.
Yeah.
That is how to win the lottery with Grasshopper.
How?
There is a video. You have the secret in YouTube. I have to say that if I would have won the lottery, maybe we would not have been talking at this point. Maybe I would be between palm trees and something like that. But
I hope so. One day we have a call and you are around palm Bugatti.
I won only a couple of euro, but for me it was enough to prove that the algorithm can create something interesting, no? But what was I talking about?
The parametric arm and Grasshopper.
Yes, the robot arm. Thank you. And so we programmed the robot arm in Grasshopper. There is a nice plugin called Robots, designed by a professional that is Vicente Soler, that he teaches at Bartlett School of Architecture in London. And so he implements different robot arms from different universities. So if he visits a university, he implements that model of the robot to the plugin. So if you're in one of those universities, you can find in the list that model of the robot from many different brands like Kuka, Fanuc, ABB, and so on. And he has designed a plugin where you can transform the path that you want to follow into targets that are basically planes that orient the tool of the robot. And so it's just it's a little more complex than 3D printing, because in 3D printing you need just points, because the 3D printer is locked to 3 axes, and the robot has multiple positions. So instead of working with a point, you work with a plane that, with the normal of the plane, you orient the tool of the robot. So you have to model the tool, you have to design the tool tip with the reference plane, and then the reference plane on the tool. Imagine that this is my tool on the robot arm. So I have to design a plane here, and this plane has to match the other planes of the geometry. So if my planes are doing something like this, the tool will match those of the plane of my geometry. Basically, it's just
so going on
coordinates.
Yeah, so all the four axes you have coordinates, and the robot will go around and probably model something that you want, something
That's
like
it.
that.
Depending on your model, for example, if you attach a hot wire cutter
Mhm.
like that, then you have to make the hot wire cutter move and cut along a path with some planes to create the model that you're looking for. If that tool is good for your model, or maybe you need to add, because the problem with the robot arm is like if you have an arm like this that does nothing,
Yeah.
so you have to add a pencil, or you have to add a milling machine, or a 3D printer, or any kind of, or a fork, any kind of tool to do something, no? And so depending on the model that you have to develop, you will have sometimes to design your own tool. It's called end effector of the robot, because
Wow.
sometimes happens that people buy the robot arm and they don't know how to create an end effector, a tool, and they just do movement of the robot without anything.
And we have to take in the consideration of the thickness of the object that we are placing in the arm as well, right? So that it is perfectly aligned with the points and the axis. Because if I have this arm, my point is this. If I put something additional to this arm, my point will shift to this. So we have to calculate this as well, like where the point will move to, right?
That's
Wow.
called that's called the tool construction plane.
Okay.
And so it's super important because the robot, for example, a 3D printer, you
Mhm.
have some experience with 3D printing?
I'm planning to buy. I have just been going on to tutorials and just have seen in the college, but I
Mhm.
haven't been using it.
Okay,
But
so it's very simple. The 3D printer has a build plate, a square, where you
Mhm.
print, no? And it has an origin of coordinates. So there is a
Yeah,
plane of coordinates, and from this zero, everything happens.
yeah.
With a robot arm, you have the plane of the robot arm, where the robot arm is attached to the ground floor,
Mhm.
and then there is another plane for the tool, because it can do any kind of movement. So it's a little more complex than just a 3D printer, because you
Yeah.
have to control a couple of more variables. But it's not that difficult. It's not that difficult. Right?
Just because you know it's a
No, 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 no,
for me,
no.
it's still like, hey, so how will I control those planes and how that things will move? Yeah.
In a few hours that someone explains you how it works, and you have the robot arm with you, and you see the tool, you got it. It's like it's easy to understand.
So,
It's,
where do you see 3D printing and these robotic arms going in the future? Like, do you think like in coming next 3 or 5 years, we will be seeing because 3D printing is something that I have made few videos on, and there are companies who are doing 3D printing on a commercial basis. Like people will be living in those 3D printed homes.
mm,
So, where do you think, like, is it a good thing, like people should start learning about 3D printers now?
yes, 3D printing has come to stay here. I mean, it's the same than AI.
Hmm.
It's one more technique. It's starting to be super common in the industry, and also in normal life, no? In people, in
Mhm.
designers, as part of the designing process. Sometimes it's not something that you use as a final model, but it's called rapid prototyping. That you have to design this in 3D,
Mhm.
uh, testing the size, the feeling, etc. You
Mhm.
before 3D printing, you have to do a mold, and then if it was not working, you had to make another mold, and those molds were extremely expensive. Just, I mean, just use it for rapid prototyping to know if the shape is working, etc. And so on. It's amazing.
Mhm.
So 3D printing is here to stay, and in the field of the industry, as you say, there's every week there are new houses 3D printed, and I think it's going to be one more technique, the same as normal all other normal ways to construct buildings, or
Yeah.
traditional ways. 3D printing. It does not mean that 3D printing is going to be the only way, not at all, but it's going
Mhm.
to be one more technique, the same as we have precasted pieces and not every building is pre-built before, precasted. No, it's just some buildings you just come and assemble pieces. Others are 3D printed, and others are done by hand, brick by brick. So of course it's gonna be one more technique that we will use normally in the future.
So this question is probably for me. So what if I buy a 3D printer, like a small scale 3D printer, and will the functioning of that 3D printer or like the file type that we send to that 3D printer be same as those big construction 3D printers as well? So the philosophy will be the same, right?
Not really. I mean, it could, but people do not use it like that. For example, when you are 3D printing this object, you're not thinking on the efficiency of the 3D printer and to use the minimum amount of material and so you just want this shape to be 3D printed. Because 3D printing is not going to be the final technique. It's going to be plastic injection, molding, and so on. But when you are doing a building with concrete 3D printing, you have to think super well what is going to be the path of that machine in order to have the thickness of the wall that you need, to save material, to save time, stability, and some others, because that's going to be the final material. And so, believe me that it is super stressing to control that part, because every single thing, every single path that you design is going to be 3D printed.
Yeah.
And so we're talking about costs, about many other things that are important. And it's a different way to use it, like to 3D print an object that you want to see the object beautiful, or a figure of Star Wars or something like that. But you could use your small 3D printer in the same way than the big 3D printer for concrete, controlling the path perfectly to do something super efficient and so on. You can use it also like that. But usually people don't use small printers in that direction. They use it to get an object that is the object that they want, and they don't care about the amount of plastic. They don't care that much about the amount of plastic used, etc.
Okay.
So it's slightly different. Also, everything that is big scale, you have to think twice. It's not like just plug, play, print, and so on. There are
a lot more things would go into picture or play. But to basically understand what 3D printing is, you can probably get a small 3D printer and start experimenting with it.
Of course, any 3D printer is gonna be fine. You know, I buy many second-hand 3D printers. After pandemic, there were many people that bought a 3D printer to do the typical masks. You remember?
Yeah.
They were 3D printed and so on, and they used them a couple of times only. And so the second-hand market is fulfilled with 3D printers that have not been used more than twice. And so my advice for everybody is buy a second-hand 3D printer that is going to be fine, and we don't need to construct more 3D printers. That there are many already there that nobody is using, and they are cheaper, and they work perfectly in general.
Awesome, sir. Awesome. So everyone who is watching this show, I hope you got to learn a lot of stuff today. And we did touch upon a lot of topic: computational design, parametric architecture, 3D printing, AI. I have never had such progressive conversation like in probably past 6 months. So again, sir, thank you so much. Thank you so much for your time. And all of you. So I can probably share your Instagram on because I have seen your Instagram, and these are like something that all the architects should know about, like the parametric architecture and the stuff that is there on his account. It's really amazing. So do go ahead and check his account out. I will mention all the links for the books, for the courses, for his company as well. in the description so that you can go ahead and have a look on what is out there and experiment. Don't be scared of going into a new field. But if you are interested into something that is going to be the future of architecture, this is it. So today we talked basically about the future of architecture. Everything that we spoke about, it's ongoing and upcoming future.
That's it. Thanks to you a lot, really, because your motivation to contact me and to say, hey, let's do this talk, and so on, that I really appreciate a lot. That makes me feel that I'm not alone in the world. I'm not alone, obviously, but that we're not only a few people doing this, that there is many people interested on learning about these fields. And people like you is super important because you reach a lot of people and they follow you, and you are a super important key part on the knowledge, on spreading the knowledge nowadays. That's it.
And so, it is actually it is very important, sir. And I think because when I was young, when I was in architecture college and just graduated, I had no clue what's going on out there, what are people doing. Right now, still, because internet has spread to every place around the world and it is in hands of everyone, so we can share a lot of stuff, we can see a lot of stuff. Like I stumbled upon your account just randomly. I was just scrolling one day and I saw that robotic arm video and I was like, oh damn, this looks cool, let's see. Then I went to your profile and I was like, okay, I have to contact this person. And I think so a lot of people will probably be motivated after this specific podcast. A lot of people don't go through a big 1 hour podcast, but the people who are actually interested, they will go through all of it. And I think a lot of people will learn a lot of stuff. So again, thank you. And to everyone, if you like this video, go ahead, hit a like and do subscribe my channel, and do go ahead and check his account out as well, because your support to our channel, our accounts, or the stuff that we do means a lot to us. It motivates us basically. If someone randomly comes to me and says like, oh, I took this course because you said it, it's a feeling good kind of effect when I get to know that. Like, I'm here in Canada because I saw your video. I'm like, wow, I hope you don't regret it. So it's something that motivates us. So yes, go ahead, subscribe, follow, and support the architects and architecture around you. So thank you.
Thank you very much. I will be happy to welcome everyone that wants to contact me. Tell me if you come from the channel and from Sarat, and I will be happy to talk to anyone and to give you also feedback.
Yes. Thank you, sir. Thank you again so much.
Thank you very much. Bye.